So 11.3, so it gives you all kinds of methods or the main methods to be used in troubleshooting a network. And now you guys are kind of beginning to see how Cisco does things. A lot of the stuff you've already done.
Mm-hmm.
They kind of throw it at you so you can get a little taste of it, and then they give you a little better in-depth coverage of it. Like, for example, the first thing they give you in learn how to test your network is the ping command. And you guys are already kind of used to doing a ping command. You're also used to that the ping command test is layer 3 connectivity. That means, what does that mean by layer 3 connectivity? Anybody want to venture to tell me?
That's the network.
Yep, that's the network. And what type of PDU is
Package.
packets? That's right. Okay, ping is usually testing whether or not packets are reaching their destination. So it makes sure that, and that's called the ICMP, which is the internet. That's a little clue right there. Internet. It tells you must be going through routers. It's on the network. So Internet Control Message Protocol is what ping is really doing. Another name for ping is ICMP, or Internet Control Message Protocol. These things you may be asked. Whenever you send out a ping from your iOS, which is from your a router or from a switch, whenever you send out a ping, you're going to get one of 3 indicators back. You'll either get a it's called exclamation point back. The exclamation point indicates a receipt of the ICMP echo reply message, which means that I got your message and I'm doing something with it. Or you will get all dots. Whenever you get a bunch of dots back or periods back, that means that something ain't working. Something ain't working, and it's going to eventually time out. It'll give you a timeout. And if you get a U back, a capital U back, that means that what the thing you tried to reach is unreachable. It's either turned off, it don't exist. The IP address you put in here is unreachable, which it probably don't exist. Or you probably put in the wrong. The first thing you will do when you get a U back is, I probably put in the wrong address. Go back and recheck your IP address you put in there, and see that you have a 1 instead of a 2 or something. So
the dot and the U, they not the same?
No, the dot and U is not the same. In fact, all 3 of them are different. But the dot is saying, I'm trying to do something. You put in the right address. I'm trying to find it, but for whatever reason, I can't find it. Which means that there may be something wrong in one of the routers that is trying to go through. It may be you, and you may have the wrong IP address for your host. But anyway, it's letting you know that I'm trying to do it. Right now, I can't find it. But if it comes back with a U, it means I tried to do it, and it doesn't even exist. It's unreachable. Or that's another way to say it don't exist. What you tried to ping don't exist. Okay. We just covered all of that. I'm gonna go through that again. I like this about the way I got this set up is that we can cover it one. Incidentally, you guys, you can ping yourself. It's called a loopback. And of course, you guys know what the loopback address is, 127.0.0.1. That is the official loopback address. And what that is telling you is that if you don't get a response back from loopback, then something is wrong with your your computer. Something is wrong because it never even gets out to the network. It just loops back on itself. So if you don't get a response back from that, then something is wrong. That's one of the first place to test. We always did that. When I test equipment and I was testing networks, the first thing I would do before I test anything else was loop back on myself to make sure that my test equipment was working and to make sure that my computer was working. And when I got a favorable loop back, then I was ready to go and try testing the network now. So anyway, that's just a little aside there, so you will know that you can test your own equipment. Okay, we talked about loopbacks. Let's see, what is this now? Okay, the same thing. Just talking about ICPM. Okay, and let's go on. Okay, extended. You probably need to know what extended ping is. Extended ping is something that Cisco offers. It's a Cisco iOS capability, and what extended ping does is you can go into extended ping, and it will walk you through the actual ping, just like trace route. It'll walk you through all the different parameters of what's going on, and you can, rather than just have it go out there and come back to you, you actually see what you can go and you can change the parameters. You can always change. Do I want timeout to be shorter or longer? You can go in and change any parameters on the extended ping. And Cisco also has an extended trace route, just like extended ping. You also can have IPv6 extended ping as well. Okay, baseline. Here is a very important concept that you guys need to know about when it comes to troubleshooting or testing your network. It's called the baseline, and you're going to be called upon as the administrator or the network engineer to establish baselines. And what is a baseline? Baseline is nothing but documenting a whole period of time of pings. You do a lot of pings over a period of time. You do a lot of trace routes over a period of time. You do a lot of different tests. As a matter of fact, because I was a network engineer, when I would go TDY means temporary duty in the Air Force, and I would go to test a customer's network, the first thing I would do, like the first 2 days I'm there, they were easy days for me. They were like vacation days, because I would go into that office and set up automatic testing, automatic pinging, automatic trace routes, all kind of automatic testing. I would set it up, automatic loopbacks, and then I had a recorder that record the results of all of my testing. And I come back in a couple of days, and but no, it wasn't that simple. I would be checking to make sure indeed it was recording what I needed. I go in every now and then and check to see what was recording. I get back a couple of days, and I'd have a baseline established. And really, after I get all those results back from that baseline, I can say, you know what? I know exactly what's wrong with your network. In fact, I know where it is. I know where the problem is right now. Because that baseline will show you real quick that, okay, here the times are up to here. Now they're down to there. And they only go down at this router, or they only go down at this device. There's a problem with this device. So baselines are extremely important. Like I said,
Baselines are just like a list of procedures you made over time to check
that's exactly
if
right.
everything's right.
Here it says it right here. A network baseline is built over a period of time. You have saved results from commands such as pings and trace routes and error messages. You have over a period of time. And they're time stamped for later comparison. That's important too. Every command is time stamped, so you know what time it was issued and what time you got the results back. And usually, if there was an increase in time, then you almost automatically know that there's a latency problem. Something is causing that signal to slow down for some reason. And you can almost find out where the problem is real fast. So knowing how to do a baseline, knowing that it's over a period of time is important. I mean, you know, all you're getting is a snapshot if you go there and just take a ping or take a ping. All you get is a snapshot. It don't really tell you that much. But if you got a ping over a 24-hour period, and you got about 300 pings, or you got a pretty good idea of what's going on. Pretty good idea of what's going on. So that's what a baseline is all about. That's what it's all about. Okay. Interpreting trace messages. Trace route. There's two kinds of trace routes. There's one trace route that you get that comes from nothing but your computer or from your terminal. And that's called a trace route, R-O-U-T-E. Then there's another trace route or trace RT that you get when you test or you trace it from the switch itself or from the router itself. So it's two different kinds of trace routes. One is you're testing from your terminal, which is where you are, or you're testing from the router itself. And each one will give you their own types of results. Okay. It says when performing the trace route at a Windows computer, use trace RT. And when performing, I got them backwards. That's right. When performing the one at Windows or at your terminal, use trace RT. When performing the one from your router or from the device or from the CLI, use trace route. Spell it out, R-O-U-T-E. So it's important that you know that because that's two different commands that you'll be using for trace route. And basically what trace route is doing, what's happening in trace route is, well, I don't want to go to, I'm not going to extend it yet. What's happening in trace route is it's tracing the flow of these packets. You send out a test signal or a test packet, and it's tracing is that packet getting all the way through to your destination. And what it does is more important. It gives you more information than a ping does. Trace route tells you where the packet failed. It tells you exactly which router or where the packet went to and it stopped. But it tells you via a IP address. So you got to know the IP address for that router or for that switch. You got to say, it actually failed at, IP address 168.142.10.3. And where is that? Oh, that's at this, that's at switch. I mean, that's at switch S2. So trace route tells you a lot of good information about where the problem is. And trace route is something that you can use immediately. You ain't got to wait and do a baseline. You can start doing troubleshooting immediately. But the beauty thing about a baseline is that you ain't got to sit there for 8 hours and let me test this switch. Let me test this route. Let me test this router. Let me test this. You can just set up a broadcast test for all of them, and go to McDonald's, eat, go to park, have some fun, and come back and see what the results are. That's
How long does it take though?
Huh?
To do the whole baseline.
Depend on how many switches and routers you got out there. But I mean, it'll take you about an hour and a half to get them all set up. Once you got them all set up, you can go. But I still advise you to check back in about every 2 hours to make sure it's working.
Yeah.
Because the worst thing you do is come back 24 hours and you didn't set it up right. You just lost the whole day. And your customer ain't going to be happy at all. So it's just wise to check back every couple hours, make sure it is working, that you are getting results, and that you can read it. But that is what traceroute does. And then same thing like extended ping, there's extended traceroute. An extended traceroute, here again, gives you the ability to go in and go element by element. In other words, you can say you can change any parameter. It don't just automatically go out there and test and come back. You can watch it go down element by element. You can go in and say, I want to change, like I said, the TTL, which is the time to life, and I want to change. And there are about 10 different elements or 10 different parameters to echo or trace route. Okay, and this just tells you how you do extended trace route. Instead of you typing in trace route, you just type in. You don't put in a IP address. You just put in the term trace route, and then hit enter, and then it'll bring up extended trace route. You just start walking through it. As opposed to if you're doing a real trace route, you got to put in trace route, and then put the IP address, and then it goes and it does the whole thing on its own automatically. Okay, but that's extended trace route. Here they are. Here are the if you guys can see these, there are about 10 different trace route options when you are doing an extended trace route. There are about you can do a -D, which means you don't really want to address any host names. You can do a -H, which means that you set the number of maximum hops to go to. You don't want to test all of the routers. You just want to test a few of them. You can do a -J, where you want to put out the specific host that you want to go to, or a host list that you want to go to. You can do a -W, which means that you want to change the wait timeout. You can do a -R, and I guess which means you can change your round trip path. You wanted to go out one way and come back another way. That's use a -R to do that. You can do a -S, which is your source address. And you want to change your source address, which means I don't want to test from my router that I'm at. I want to test from another router or another host. You can change that. And you can also do a -4 or a -6. A -4 said I want to do nothing but IPv4 trace routes. And if it's -6, I want to do IPv6 trace routes only. So those are the different options you can change when you're doing a trace route test. Okay, and I'm going a little too slow. Got to pick it up a little bit here. Okay, now we get into the show commands. I'm not going to do a lot on these show commands because you guys, as you can see, you've had lots of experience with show commands. Hopefully you have lots of experience with show commands because we've done a lot of troubleshooting packet tracers, and we should know most of these show commands. So I'm gonna cover these real fast, and you see they give you the most common ones, which is show running config, show interface, show ARP, show IP route, show protocols, and show versions. Now I gave you guys a whole list of show commands, but these are the ones most commonly used to troubleshoot a network. And let me just tell you kind of what each one is. Go through them real quick. Show running config, you guys should be used to that by now. It shows everything that has been changed on the device configuration. Did you change any interfaces? Did you give it new IP addresses? Did you change gateway addresses? Anything that you've changed on that interface? Did you change the host name? Did you change anything that you changed on that router or that switch? Should show up when you do a show running config. You should be familiar with that. Show interface. This is my favorite one. My favorite two troubleshooting shows is show interface and show interface IP interface brief. Show interface. What it says, it shows the different devices interfaces and their status. If you want to know if an interface is turned up or turned down, you can do a show interface. Or you should do, I always do show IP interface brief, which tell me if it's working or not working. And many times, the first thing you do after you do a trace route or you do a ping, and you find that it hit a certain router and didn't go any further, I go to that router and do a show IP interface brief. And I say, oh, it ain't even turned up. Let me go turn it up. Boom, you just solved the whole problem. You can go home. That's why shows are so important, man. Know what they are and know how to use them, because they will save you a lot of time. Show ARP, I kind of like this one too. You guys know what ARP means. It's Address Resolution Protocol. And it shows what address is resolved to what IP address is resolved to what MAC address. And many times you can go find out that the MAC address can tell you what the device is. Is it a router? Is it a switch? Is it a hub? Is it a terminal? What is it? And once you know that, you know which one it is, and you can go say, okay, there's no IP address for it. That's the problem. It has no IP address. Let me go assign them an IP address, and away you go. So show ARP is another very powerful command because it lets you know what you got. Show IP route. Next, Right now, IP route ain't doing you guys a whole lot of good, even though you probably used it a couple of times. But when you get into CCNA 2, this gonna be your boy here. This gonna be your boy. Show IP route. It'll show you what is in the routing table. It shows you where things have been set up in the routing table and whether they are set up right. And that routing table is so important to know what's in it, and to know what's directly connected and what was learned from the just the routing protocol. So so you guys are going to get used to show IP route. I want to look at the routing table. Show protocols. I use it sometimes, but show protocols really, it shows the status of each interface, and it shows that's good for especially when you're testing a switch as opposed to testing a router. But it shows the status of each interface and whether or not that particular interface protocol is operating, or is it up or is it down? Well, it shows you two things may be wrong with the interface. Either it's not turned up, which means somebody forgot to type, what is it? No
shut.
Yeah, no shut. That means somebody just didn't type no shut to turn it up. Or it shows that the protocol itself is not activated, which means that you either got the IP address wrong, or you got the subnet mask wrong. So it'll give you information about that's why the interface is not working.
Already.
Okay, show version. I do that when I first come to a site, and I try to see what's on the device. And many times you get there and find that it's got an old version. All the rest of them got version 10.6.3, and this thing still got 10.6.2. And you say, there's the problem. It's got the wrong version. So you just download the right version, update it, and away you go. So many times, and be sure you look at this video on 11.3.3.2. That video will show you how show version works. And like, I don't use it that often, but I use it when I think, and believe me, when you start testing networks, it becomes very important, because you may have an administrator who just didn't keep the versions up. As long as nobody was complaining, he didn't care. That's not good. That's not good. Okay, that's all your show commands. Make sure you understand the -D for your ARP command. When you do a -A on your ARP command, the -A will list all the devices that are currently in your ARP cache. That means whatever has been learned and is put into the ARP cache. You know how the ARP cache works is that every time it goes out and there's a new device on the network that it didn't know the last time, it says, there's a new switch out there. Okay, please send me your MAC address. So it then matches that MAC address with the IP address. So in its ARP table, you call it ARP table or ARP cache, is the same thing. But in your ARP table, it knows every device on the network. Everybody knows everybody else. Know who's on the network and what's their address. Now you can do a clear the whole cache, was what was called the ARP, the -D. You can type in the -D, and it will clear, you say ARC-D, and it'll clear the whole cache or the whole table, and then it start over again. So you need to know what that -D is about, what -A is about for ARC. Default gateway. An IP address of the default gateway of a host. It's really, I mean, IP config shows you all the different configurations for a particular interface. If you type in IP config for a particular interface, it will give you. In other words, you got to be on the line mode. And once you're at the line mode, you can type in IP config, and it will tell you the IP address for that particular interface. You can find out what is its information. So IP config is also another pretty important command that you can use, especially when you're trying to find out about the default gateway. I really like this little feature that Cisco has built into there. It's called Cisco Discovery Protocol, or CDP. And whenever you type in show CDP, what it does, CDP automatically goes out and discovers everything around it. In other words, if it's a switch, you're sending out CDP. If all the neighboring switches got CDP, then it will go out and find out who its neighbor is. It spies on its neighbor. It knows all the information about its neighbor, and of course the neighbor knows all the information about it. So everybody knows what everybody else has got, all in the network. And whenever you do show CDP neighbor, it will show you every switch or every router that's directly connected to that switch that you're looking at. So here's a Cisco Discovery Protocol. It's also a very important feature. All routers don't have this. Only Cisco has it. Everybody else don't have CDP. But it's a very important show CDP neighbors. It's very important for you to troubleshoot and find out. And you guys are going to see in CCNA 2, CCNA 3, you'll be doing a lot of troubleshooting. And you're going to need to know these commands. You're going to need to know how to do a CDP neighbor, so you can find out, is the problem further out in the network, or is it right around me? And once you figure that out, you're trying to get to where the problem is as fast as you can. And all these little troubleshooting commands will help you get there quickly. Let me see. When a Cisco device boots up, it automatically turns CDP on, and it goes out to find out, do all my neighbors have CDP? And if they don't, it just sort of shuts them out and only talks to the one that got CDP. Let's see. Here are some of the things some of the information you will get back from CDP when it spies on its neighbor. It'll tell you things like the device identifier, which is the actual host name for that device. It'll tell you what the device list, which is all the different type of network addresses that are actually supported on that device. It'll tell you the actual port identifier, which is nothing but is it a fast fast Ethernet 0.0 or gigabit 0.0.0. It'll just tell you what that support identifier is. It gives you capability list, which is nothing but is what kind of device is it? Is it a router? Is it a hub? Is it a switch? What is it? And it also will give you what platform, which will tell you the nomenclature. Is it a Cisco 1841, a Cisco 1921? What kind of device? What's the nomenclature of it? All that comes from when you do one CDP inquiry. It gives you all that good stuff on just one inquiry. Okay, and incidentally, you gotta type in the term show CDP neighbor detail to get all of that, to make sure you got everything that you need to know about your neighbor. Okay, I'm not gonna go into this. You guys know about show interface brief. Like I said, it is my favorite command of all the Cisco commands because it will give me what I really need to know. If you do show interface, it's gonna tell you everything about the interface. You don't need to know everything. It's just too much information, just TMI. But if you do a show interface brief, it'll give you what you really need to know to see if that interface working or not. So I very seldom do a show interface because it just gives you everything there's to know about that interface. I don't need to know everything. I just want to know, is it working? Is it working? Is it up? And that's what show interface brief does. It verify the router interfaces. And then you got you can also verify your switch interfaces. And usually what you want to do to verify those, you can use a show interface brief to verify your switch interfaces. But it will yeah, you can use both for router or switch interfaces. Show interface brief. Debugging, I almost never use this, but debugging tells you everything about the iOS, it debugs whatever is in the iOS. It will tell you what's going on with that switch or that router via its iOS, and it tells you everything like what it generates different messages to let you know that what's going on in that particular iOS and what's going on in that switch, as a matter of fact, and these are real-time messages. So if you turn on debug, when you type in turn on debug, it can really become a hassle because you can go get those messages. They come automatically. They just keep coming, and you can't do anything else for all these messages coming in. And that's what debugging is there to give you all that information about the iOS of that switch and what's going on with it. And you really don't need all that unless you really are trying to do a debug. So you can turn it off by using no debug ICMP, or you can turn it on by just typing in debug ICMP, IP ICMP. If you put no in front of it, then it turns it off. Or you can type in undebug. If you type in undebug, it turns the whole capability off. It just turns it off altogether. And many times I go into Raj, I just type in undebug because I don't, it really becomes a nuisance if you're not really trying to debug that switch or that router. Okay, but that is the debugging command. And then you got the the terminal monitor command. Terminal monitor is whenever you are logging into a switch remotely. Now, there's two ways to get into a switch or to any device. You can either do a console directly, which when you got to be there. You got to be there at that switch. You got to be in the same building, in the same room, and plug your terminal, your console terminal, or your console cable into that switch. You got to physically be there. Or you can do it remotely. If you do it remotely, you can be in Chicago and look into a switch that's in New York by doing it remotely. You ain't got to actually be there. But whenever you do it remotely, there are certain messages that you cannot see. You can only see them if you are plugged directly into it. So whenever you want to see all those different debug messages and other kind of troubleshooting messages that you want to get, you got to do what is called terminal monitor command, which will say, I want to get everything that I would get if I was directly as a terminal plugged into this switch or to this router. And that's what that command do for you. Terminal monitor command actually brings up everything that you need to see on your terminal, even though you're remotely, or you way away from it. You're too still, but you still can see everything. Okay, and that's all there is about terminal monitor. All the different log messages, what's going on. Okay, now we're gonna go into the troubleshooting, the different troubleshooting techniques, and we'll be through for the day when we finish troubleshooting techniques. It's important for you guys to know this, that troubleshooting, there are basically 6 steps to troubleshooting. And this is called the scientific method. If you guys ever into a technical field, like if you were a chemist, or you are a biologist, or you are a physicist, you will become very familiar with the scientific method. Everything, even today, CDC, all of these guys still use the old scientific method because it works. I mean, it's just like the Bible, man. The Bible may be, thousands of years old, but boy, it still works. It works. And the truth of the scientific method, it still works. And there's 6 steps that you apply in troubleshooting. The basic is, number 1, identify the problem. You got to know what the problem is. I identify that there is. By that I mean, like, for example, if you're testing a network and you see that everything is stopping at router 2, and you say, "Oh, well, the problem is router 2." You don't know what the real problem is, but you know it's at router 2. So you've identified the problem. Then you got to establish a theory of probable cause. You say, I think it may be the serial interface. I'm not sure yet, but I think it may be the serial interface on router 2. So now you have put together a theory of what you think it might be. That tells you what to go after next. And then you will test your theory. You start using the show interface command or whatever command you want to use to test to see if your theory is right. If you go in there and say, "Oh, okay, that interface is up, so it's not that one. So my theory was wrong." But it may be one of the Ethernet interfaces. Let me test. I bet you it's F00. Let me test that one. And that's a new theory you got now. And you go and you test it, And there it is. That's the one that's down. And then once you have done that, you got to put together a plan of action for fixing it. And so you got to go and say, I need to assign an IP address to F00. And you go and you assign an IP address and turn it up. And now you're ready to do what? What would you do, guys, to test the functionality?
Ping.
Ping, there you go. There you go, man. You guys got it. You want to do a quick ping on it to test its functionality. And to be honest with you guys, when you're doing this stuff in the field, you ain't even thinking about the scientific method. You're just going through it. But you are going through the scientific method every time. Every time you're doing it. But you did it so many times that you're just used to it. So you don't think about scientific method. So like I said, like driving a car, you don't think about it. You just do it. And then once you've done that, you want to document it. You want to show them, because you got to get back to your customer and say, look here, one of your guys then put an IP address for this interface. You need to get on them. You got to have one for every interface, okay? You got to document, say, you got to document. I took a picture of it here, no IP address. I took a picture when I set it up. It works fine. Your guys are messing up. And then you gone. You earned your money and you gone. But that's called the sixth step of the scientific method or the troubleshooting method. It is still used widely. There is and I love this one. I do this all the time myself. It's called resolve and escalate. Resolve or escalate. Resolve or escalate means, look, I've tested it. This is really out of my hand. It's out of the scope of what I can do. So I'm going to escalate it to somebody that's above me and let them test it. And that's what almost every network is divided into, those kinds of resolve or escalate. They'll always say, okay, I'm a level 1 tester. And if I can't resolve your problem, Mr. Customer, I'm going to escalate to a level 2 tester. He has more equipment, more knowledge about your network than I do. And you get it off of you. And you give it to a level 2. And if level 2 can't resolve it, he's going to escalate it to an architect who knows your whole network. And he say, if I can't resolve it, he can see the big picture. We'll escalate it to him, and he will get it solved for you, Mr. Customer, and you through with it. That's called resolve or escalate. Okay, verify and monitor solutions. We talked about that. I'm not going to get into that. You guys know that ping and trace route and show commands are the things you use to verify and monitor, especially ping and trace route, because you can set them up. You can set ping or trace route to go automatically, so they can literally monitor your command. You guys haven't done much work with Wireshark, but you will get used to it. Wireshark lets you set stuff up automatically. And you can do automatic pings and automatic trace routes, and it can do all that good stuff to let you test that network even though you're not there. And that's called verify and monitor. And of course, show commands is your main command for verifying. I love that show command. The show command tells you what's there right now. What's there? Duplex. You get used to this because this gets messed up so many times on the network. So many times. Duplex is whenever you got a duplex interface connected to a simplex or a half duplex interface. A duplex interface is looking for, I'm gonna send it out on this cable, it come back on that cable. But a half duplex, so I'm gonna send out this cable, come back on the same cable. That messes you up, man. If somebody didn't, if a network engineer or technician didn't program both of those interfaces to be full duplex, you got a problem. You got a problem. And some of your interfaces are set up to auto negotiate. Well, that's good if you got the right, if they both got the right update or the right versions, because every version don't have auto negotiate. And if they don't have it, it'll never set up full duplex. But it say, look, I'm duplex. What are you? He said, oh, I'm half duplex. Change to full duplex so we can talk. And the other guy maybe said, no, you change to half duplex because we only got one cable between us. But that's what auto negotiation does, to make sure that they both interfaces are on the same sheet of paper, duplex. Okay, and then you need to be able to document whether it's a duplex mismatch. Here again, you got to always go back to that boss or to your customer and say, look, somebody programmed or configured this interface wrong. It should have been configured. Both should be full duplex, and one of them is half duplex. And that's your problem. You have a duplex mismatch, and that can sometimes be a hard problem to find if you don't know what you're looking for, what you're doing. One good way to detect a duplex mismatch is a CDP. That's why I love CDP. Cisco Discovery Protocol will go out there and ask those questions for you. It'll ask that interface, okay, what do you got? I'm on duplex. Okay, I'm on duplex too. We're good. So CDP, or it will report to you a message that we have a duplex mismatch. So when you do a show CDP, man, that's a powerful thing to do because it can tell you a lot of what's going on. When you say show CDP neighbor, it tells you what's going on. It can detect a duplex mismatch. And it talks about the different log messages that you get. Also, I'll tell you guys about when you're doing a monitor, show the monitor command. All these log messages will tell you if there's a duplex mismatch. So these are just a couple of ways that you can go check and see what's going on, either via your monitor log messages or via your CDP messages, CDP log. IP address. If you got an IP address problem, it's usually easy to detect an IP address problem. But here's the problem: with you have the wrong IP address. The biggest problem you're going to have is, do you have DHCP turned on? I mean, when you got an IP address problem, there's either one or two things going on. Either somebody put the wrong IP address in there manually, or DHCP is operating. And what is DHCP, guys? Y'all tell me.
Dynamic host configuration protocol.
There you go. That's it. It's actually assigning an IP address over and over again. It's reusing an IP address. Whenever you log on to the network and you don't have an IP address, it's going to assign you one. But guess what? If DHCP, and you guys will be responsible for making sure that this is set up right, if DHCP doesn't have the same network range that is on yours. It's gonna sound you an address, but it's gonna be out of the range of your network, and it ain't gonna work. So many times DHCP makes the mistake. It's a DHCP issue, and that's why you guys, when you set up networks, you got to be sure, and you're gonna learn about NAT and all the different ways of setting up DHCP to make sure that it is indeed at least assigning IP addresses that are in the same network range as the network that you own. That's why it's so important for you guys to learn about subnetting and learn about network ranges. And if it's outside of that range, it's not going to work. It's not going to work. So these are some of the issues you got to check out. You got to say, is DHCP turned on? Yes, it is. What IP address it is assigning? Oh, there it is. It's in the wrong network. No wonder it's not working. So here again, my favorite command, show IP interface or show IP interface brief, will show you exactly what DHCP is doing, whether it's assigning the right address or not. It'll show it to you. So I have solved so many problems on networks with these two little commands. It's incredible. Well, I'll go in and do a show IP interface brief. Look at all my interfaces. Aha, there it is. That rascal is not on the right network that his counterpart is on. Let me go in and put him a new IP address in there so he can work too. And but I learned it from show IP interface brief. Just that quick. Save a lot of time. Okay, if you got IP, and this is basically saying what I just told you guys about, is that DHCP will have a set of range it's going to automatically assign, and if it hasn't been set up right, it's going to assign from that range, period. And like I said, your network may not be on that range, or your device may not be in that particular network. So you need to know that. That's usually if you got a problem with an end device not working, like a server that's not working, that can't get on the network, or you can't get to the server, or you got somebody's computer can't get on the network. You got to go look at, are they on DHCP, and what is it assigned to your computer? And you may have to say, we got to turn DHCP off. We got to just assign you a hard wired so that you can work. But that's what you do. That's what we do. The gateway, whenever there's a gateway problem, it's just because the default gateway is the path to remote network. Its address must be on the same network as the end devices. That is always a huge, that's the next thing I look at. Is I look at the host device first, and then I look at the gateway. I say, okay, is that gateway the same thing as the interface on that router? If it's not, we got a problem. So this just trying to give you an idea of what to look at first, what to look at next, and you want to look at end devices first. Is it using DHCP or not? Was it assigned, set up right? And you guys, once y'all get good at this, you'll have your own list of priorities. You'll walk into somebody's network, say, I'm gonna look at these things first, these things next, these things next, these things next, because you will know that 9 times out of 10 is in the first thing I'm gonna look at, because you want to get the problem solved as fast as possible. So it's good to already have you a list of priorities of things you want to look at before you even get there. And default gateway is one of them. Let's see here. Okay, DNS. Okay. All right, guys. So what is DNS?
Naming system.
There you go. Domain name services. And that's and believe me, it can get messed up too. Just like DHCP, it can get messed up as well. Because it's anything it's automatically, you know, whenever you automatically assign anything, garbage in is garbage out. Just that simple. And if the DNS server was programmed wrong, it's going to assign the wrong name to the wrong IP address, and you will never be able to get to that website. You'll never get there. So DNS resolution could be crucial. As I said, it's very important to the end user. We all know that. And your main 2 commands for resolving a DNS problem is the IP config all or NS lookup, depending on whether you're in the switch itself or the net router itself, or if you're on the terminal, if you're in Windows. NS lookup can manually place. When you do NS lookup, it will go out and do a manual query to the DNS server, and it'll tell you whether or not are you even reaching the DNS server, and if you are, what is it giving back to you? So these 2 commands will give you the ability to analyze what are you talking to the DNS server, or are you even getting a proper response that you want to. If you keep trying to get to a website, you type it in the the actual .com or .org or whatever, and it never brings up. It'll usually give you a error command. An error can usually tell you that I can't reach the DNS server, basically, and then you will know where to go from there. But that's when you are trying to address troubleshooting DNS issues. And that's it. That's it, guys. We've covered basically everything you need for chapter 11.